Today we shall discuss with exercise 12.3, which deals with section formula. You people have done section formula in class 10. The same thing we will continue, but this time it will include the Z coordinate. Okay. First, let us discuss the section formula. Look here at the top. The first section formula, which we call as the internal division formula. The coordinates of the point R, which divides the line segment joining two points x1, y1, z1, and Q, another point x2, y2, z2, internally in the ratio m is to n r. Now what is the coordinate? X coordinate is mx2 plus nx1 divided by m plus n, comma, the y coordinate is my2 plus ny1 divided by m plus n, and one more additional, the z coordinate is mz2 plus nz1 divided by m plus n. So this is the internal division formula. Next, we have the external division formula, which is same as internal division formula, only change is in the sign. In the numerator and in the denominator, you can see plus has been replaced by minus. So R is a point which is dividing externally. Okay, externally the points P and Q in the ratio m is to n. Now, the third one, we have the midpoint formula. In case R is the midpoint of PQ, then what will be the section formula, which we call as the midpoint formula? The midpoint formula will be x1 plus x2 divided by 2, comma, the y coordinate will be y1 plus y2 divided by 2, and the z coordinate will be z1 plus z2 divided by 2. Next, let us begin with the exercise. Exercise 12.3, question number 1. Now, what is the question? Let us see here. Find the coordinates of the point which divides the line segment joining the 2 points. 2 points are given to you. In the ratio, there are 2 sub-questions. Number 1, 2 is to 3 internally, and number 2, the second question is 2 is to 3 externally. Now, for the first part, we are going to use the internal division formula. So, in the diagram, you can see that there are 2 points, A and B, which are given in the question. We have named those 2 points as A and B. And let us suppose that P is a point whose coordinate is x, y, z. And this point P, let us suppose that it is dividing the line segment AB in the ratio, given ratio 2 is to 3. So, m is to n. In this question, m is to n is 2 is to 3. And the 2 points A, x1, y1, z1 is minus 2, 3, 5. And the second point B, x2, y2, z2 is 1, minus 4, 6. So here we are going to use the internal division formula. If you see, first the x coordinate has been calculated. X coordinate, how did they calculate the x coordinate? Using the formula mx2 plus nx1 divided by m plus n. And after calculating, they found it to be minus 4 by 5. Then next they calculated the y coordinate using the section formula my2 plus ny1 divided by m plus n. Answer came out to be 1 by 5. Third, they calculated the z coordinate using the formula mz2 plus nz1 divided by m plus n. M plus n is 2 is to 3, so 2 plus 3. And the z coordinate came out to be 27 by 5. Hence, the answer is the point minus 4 by 5, comma 1 by 5 and 27 by 5. Next, number 2. Number 2 is the external division formula. The use of the application of external division formula in number 2. Here also the same question has been given to you, but this time it has been mentioned in the question that you have to use the external division formula, the ratio being the same 2:3. So in point number 2, we are going to use the external division formula, same as the internal division formula, but if you observe, wait, let me just go to that previous slide. Yes, if you observe what is done in this point number 2, the formula in the numerator and in the denominator, plus sign has been replaced by minus sign. So, if you see the x coordinate, it has been used by the formula mx2 minus nx1. Minus is there, divided by m minus n. Because we are using external division formula, m minus n, 2 minus 3. Same way, the y coordinate, my2 minus, see there's a minus sign in between, ny1 divided by m minus n. And finally, the z coordinate is obtained by using the formula mz2 minus nz1 divided by m minus n. Thereby, we obtain the point. Next, question number 2. Let us see the question. Okay, here in this question, it is given that P and Q and R, these 3 points are collinear. Collinear means they lie on the same straight line. You have to find out the ratio in which Q divides PR. So we don't know the ratio. Now, here is an important point to be noted. If we are asked to calculate the ratio which is not known to us, then we don't consider the ratio to be m:n. Rather, the trick is, the simplest way is, we consider the ratio k:1. So here also, we shall begin with the introduction considering the ratio to be q:1. So let us begin the solution. Introduction given. See the first line. Let Q divides PR in the ratio k:1. I told you, don't consider m:n. It will not be wrong, but this is the simplest way out. Then the coordinates of Q are. So how did we obtain the coordinate of Q? Using the internal division formula. See the diagram, you can see the coordinate of Q. In the diagram, you can see P and Q are 2 points and we are considering Q to be dividing PR in the ratio k:1. So, we find out the coordinate of Q in terms of K using internal division formula. So, the coordinate of Q thus obtained is 9k plus 3 divided by k plus 1, comma 8k plus 2 divided by k plus 1, comma minus 10k minus 4 divided by k plus 1. So, internal division formula has been used. Now, this is the coordinate of Q after using internal division formula in terms of k. But actually, if we go to the question, we do have a coordinate of Q. So, what is the coordinate of Q mentioned in the question? 5, 4, minus 6. So, hence, this coordinate of Q given in the question will coincide with the coordinate of Q we have obtained in terms of K. So, now we equate the X coordinate, Y coordinate and Z coordinate. So, when we equate, the first equation that we get after equating the coordinates of Q, 9k plus 3 by k plus 1 equals to 5. And the other two equations are as follows. Now, you need not go for all the 3 equations. Any one equation you can consider, and then we can solve this equation, and we can find out the value of k. See, any one equation you consider out of the above three. So here, if you consider the first equation, 9k plus 3 equals to 5k plus 5. This, if you solve, you get the value of k to be 1 by 2. Hence, the conclusion, Q divides PR in the ratio 1:2. Next, question number 3. Question number 3. Find the ratio in which the YZ plane divides. Okay, here you're asked to find ratio. So we are going to consider the ratio to be k:1. But one important point, we are talking about YZ plane here. YZ plane is dividing the line segment formed by joining 2 points. Now YZ plane, what is the equation of YZ plane? First important point to be noted. In exercise 12.1, we have learned equation of YZ plane. Which one is missing? X is missing. So equation of YZ plane is x equals to 0. The one which is missing will be equal to 0. So here equation of YZ plane is x equals to 0. We are going to use this point in further steps. So let us begin with the introduction. Let YZ plane divide the line segment joining the 2 points A and B. We are naming the points at the point P, X, Y, Z in the ratio k:1. Okay, I told you, unknown ratio. Whenever there is unknown ratio, consider it as k:1. Then we find the coordinate of P using the internal division formula. Okay, so after using internal division formula, what we have? 3k minus 2 by k plus 1 minus 5k plus 4 divided by k plus 1, 8k plus 7 divided by k plus 1. This is the internal division formula. Now, this is the coordinate of P. Now, in the question, what we know, that the point P lies in the YZ plane. It's given to us in the question. The point lies on the YZ plane. So that means x coordinate will be 0. So if we consider x coordinate to be 0, what is the x coordinate of P? 3k minus 2 divided by k plus 1. We are going to equate it with 0. So after equating with 0, then we try to solve this equation and we get the value of k. So that will be the required ratio. Now, next, question number 4. Using section formula, let me read the question. Using section formula, show that the points A, B and C are collinear. Now, similar type of question we dealt in the previous exercise also, 12.2, distance formula. It was also mentioned there to show that the 3 points are collinear. But it was mentioned using distance formula. So when we have the question mentioned using distance formula, what we do? Sum of 2 sides equals to third side we show. But here they are not asking distance formula. They are asking us to use section formula. So what is the procedure? For this, we take any one of the points out of A, B, C. Let us take the point C. And we consider the point C to divide the line joining A and B in the ratio k:1. Then we find out the coordinate of C using internal division formula. Okay, see the diagram. We consider C to be dividing AB in the ratio k:1, and then we find out the coordinate of C in terms of k using distance formula. Now, this coordinate of C is going to be same as the coordinate of C that is given to us in the question. So that means we have to equate them. So we equate the x coordinate with 0. Minus k plus 2 divided by k plus 1 equals to 0. We equate it. Next, we equate twice k y coordinate, twice k minus 3 by k plus 1 with 1 by 3. Third, we equate k plus 4 by k plus 1 with 2. So we have 3 equations now. Now, once we have 3 equations, what we do, we solve. See, these are the 3 equations that we have. And we try to solve. See, these are the 3 equations we are having. And we try to solve these equations and we obtain the value of k. Now, what we observe? In each of these cases, the value of k comes out to be the same. So, we conclude, since the value of k is same, we conclude that the points ABC are collinear and C divides AB in the ratio. What is the ratio? 2:1. Okay, initially we considered the ratio to be k is to 1. Now the value of k is 2. So 2:1. So this is all about question number 4. Next, we go to the last question, question number 5. Now, what is question number 5? Let us read the question number 5. Okay, find the coordinates of the points which trisect. Now, what do you mean by the word trisect? Trisect means dividing a line segment into 3 equal parts. So, we have to find out the coordinates of the point which trisect the line segment joining the points P and Q. First, let us go to the diagram. Now, look at the diagram. What is there in the diagram? Here, check the diagram. We have a line segment PQ where we have taken another 2 points R and S. Okay, so R and S are 2 points within the line segment PQ such that these point R and S divide the line segment PQ into 3 equal parts. So when I say 3 equal parts, what does it mean? It means PR is to RS, okay, is to SQ. So all will be equal. 1:1:1. I repeat, PR is to RS is to SQ. All will be equal to 1:1:1. That means 3 equal parts. Now, let us forget about the point Q. Let us forget about the point Q. Let us go to the second diagram. We consider only the point R. So, let us forget about the point S. And we consider the point R. Now, what happens? We find that point R, if you check the first figure and the second figure, it's similar. Only we have disappeared the point S for a while. So point R is dividing PQ in the ratio 1:2. Because PR, 1 part. RQ, how many parts are there in RQ? 2 parts are there. So 1:2. Now the ratio is 1:2. We know the coordinate of P. We know the coordinate of Q. Hence, we can calculate the coordinate of R using internal division formula. So you can see we have calculated the coordinate of R using distance formula. Using internal division formula. So the coordinate of R came out to be 6 minus 4 minus 2. Now, we again go back to the diagram and this time we forget about the point R. We consider the point S. Now, if we consider the point S, then what do we see? That the ratio PS is to SQ. This ratio is 2:1. PS, there are 2 parts in PS and SQ 1 part. So the ratio has changed. Earlier in first case, the ratio was 1:2. Now in the second case, the ratio is 2:1. And the points P and Q, their coordinates are already known to us. So we further calculate the coordinate of point S using internal division formula. Once again, we apply internal division formula and we try to find out the coordinate of S. So this is look at the coordinate of S. It has been calculated using internal division formula. So finally, we have two coordinates. One is the coordinate of R and the other is the coordinate of S.